Okay, thank you very much. Let us introduce our new product, AirCoat by Solnil, as a cladding layer for photonic metasurfaces and photonic integrated circuits. So first of all, Solnil is a spin-off of Marseille University, created in 2020, and today we have 12 people on a payroll. We're in the south of France. And our technology and products are based on inorganic resins that can be deposited by liquid deposition to form 2D coatings, or they can be directly printed in an etch-free nano-imprint lithography process to produce three-dimensional metasurfaces, or finally, can be directly deposited onto three-dimensional metasurfaces. So they can be used as a cladding layer for three-dimensional objects. So our difference is that we provide materials with extreme properties, and the advantage is that we can do these with a much lower capital expenditure and lower cost of ownership with a greener process. Today, I want to introduce the AirCoat. Is a new generation of nanostructured material bridging dense and porous optical layers. It's basically composed of void and silicon dioxide, and it almost matches the refractive index of air because it has a refractive index of 1.12. So it is extremely low, but it has high optical quality. For example, the absorption is very low, below 0.03% across the visible spectrum, and the haze, which is associated to scattering, is well below 0.1%. This is comparable to the fused silica substrate. So you have a very low refractive index in a transparent and robust material and a process-compatible form. Here I show a few examples of application. Typically, we want to apply these to fill small nano cavities and to protect three-dimensional structure, for example, metasurfaces or photonic integrated circuits. The point here is that we produce this material on top of 3D structure with extremely low ripple. So, for example, this is very important because you can use these to deposit on top of a metasurface a second metasurface. This is the tendency of this community of stacking three-dimensional metasurfaces one on top of the other to add functionalities. So thanks to this flatness, you can use this product with a very low refractive index so to not perturb the properties of your metasurfaces or photonic integrated circuits, and with something which is extremely flat and transparent. Here I show some example of tests that have been done. For example, on 2 micrometer thick AirCoat, we measure the refractive index as a function of humidity. So from 5 to 95% humidity, the refractive index changes from 1.114 to 1.115 or a bit more, meaning that this material is water repellent. Like this property, we tested against thermal shock, humidity, UV light, adhesion, laser dicing, chemical resistance. All these features and much more have been assessed by our lead customer. So we have something that is ready to be integrated in your production lines. What is very important for a liquid resist that is transformed into a solid is the pot life. And here I'm showing that, for example, storing at 18 Celsius or 4 Celsius, you have a life well above 3 months. So it's easy storable in a conventional fridge for 3 months. So you have something which is highly stable upon time, as you have fixed processing condition in time and easy storage. And please contact us for further information, and I thank you for your attention.